Welcome to the UpKeep Pledge Pros Podcast, a podcast dedicated to unmatched value and unwavering support for our customers and the community at large. Today, we have returning my good friend, UpKeep Ambassador and industry expert, Matthew Knuth of SPM Instrumentation. Matt is a recognized expert in the field of vibration, condition monitoring, and all those fancy things and technologies that we use today and all over the place. But today, we're going to talk about something that I've been wanting to learn a lot about, and I'm sure a lot of our listeners will want to hear as well, which is slow speed monitoring. Matt and his team over at SPM have the ability to monitor down to very low speeds, and it's really cool to me. I'm not familiar with a lot of those types of things. I'm familiar with the equipment, Matt, that you are seeing on a day-to-day, week-to-week, month-to-month basis, but not the technology and the way in which you're managing and quantifying the data that you're pulling in with these types of things. So I want to kick it off like that. Matt, welcome first, and let's start rolling with it, man. Give us the soup to nuts on slow speed monitoring and what you guys are doing, and just kick it off.
Yeah, man. Appreciate it. Hey, thanks for having me back on. Happy September. I'm assuming you look so happy because your kids are back in school as well as mine.
They are.
I know we've been trying to make this happen, I think, since back in June, and now our schedules finally have aligned. So I made sure that I
Perfect.
don't ask for it back. I'm pretty sure I stole this off your booth table at SMRP last year. I won't be there this year, so hopefully, if you guys, if Ryan's listening, if you guys updated your shirts, make sure I get one in the mail if you could.
We'll hook you up. I want an SPM shirt then. We'll trade.
Yeah, sounds good. So slow speed monitoring. Very interesting, very great subject. It's something, like you said, here at SPM, we take very seriously. And I would like to believe that we're the industry experts in that.
I would agree with that.
We've become, the industry standard for low speed monitoring and really exceptional forewarning times with those types of assets.
Right.
So I guess, I got a lot of good notes for you today and different things to touch on. Typically, I don't like to read off cue cards or anything like that. But, in the world of slow speed or ultra low speed monitoring, there's some pretty key things to it. And there's a bit of a history to it. Most in the industry would say low speed monitoring. Well, as I said, let me start out. It's probably notoriously been the biggest pain point for most condition monitoring programs. Slow speed is typically classified. Some will say anything lower than 600 RPM. Some will say 300 RPM. I joke, I say anything below 1 RPM.
Hey, well, you guys go down to like,
0.1.
0.1, right?
Mm-hmm.
I mean, come on.
So 20,000 plus down to 0.1. And, some of the main reasons why it's difficult is, I'll run down my list of things that I believe are the reasons. So one, signal separation, right? It can be very difficult when you're running a low speed asset to separate and sense those small bearing signals, excitations, if you will, from the larger ones in the spectrum, larger vibration components, if you will. Early stage signals. So that's the biggest thing, like I said, that we pride ourselves on is early warning. Early stages of bearing defects, there's not a big crater in there, if you will.
Sure.
So it's a little bit difficult going back to that signal separation, right? To be able to get those, as I like to say, get those frequencies, get those signals out of the weeds, and to be able to pick up those defect frequencies that are very small, right? So in vibration, speed is everything. So the faster something goes, the more times, right, it's hitting that.
Right. There's more resonance. There's more amplification.
Amplification, amplitudes are higher, stuff like that. So with something with very low speed, the amplitudes are going to be very, very low. So
right, and less consistent, right?
Right, and anybody who's been in this business for a long time will say, well, we don't make our calls based on amplitudes alone. That's why I get a little nervous when I see a lot of the sensor tech out there and different things talking about taking overalls. Well, that's only a minute thing, right? You want to see harmonics of defect frequencies and all the other modulation, different things going on in there, not just an overall signal. We as vibration analysts, we like to look at that as type of another component of severity of something, right? So
yeah,
that gets suppressed quite a bit. Low signal, again, same kind of thing, low signal to noise ratio. Like I said, slower machines, noisy environments, right? Those signals again get suppressed down in the weeds. I'll touch base, like I just said, a little bit on the sensor stuff. Back when I first started getting into it, before a lot of this stuff kind of evolved, they would say, you need special accelerometer. Some would say, like 500 millivolts per G, more sensitive to measure those forces and things like that. But I'll touch on that a little bit too, but that technology has advanced quite a bit to where you can just use any good quality 100 millivolt per G accelerometer to a lot of this stuff. What else? Technologies that don't, what would be a good word? Ineffective technologies.
Sure.
So common technologies like vibration analysis in its pure form of taking like velocity readings isn't going to pick that up, right?
There's really no velocity, right?
Well, right, and even with even when you're doing typical monitoring of say just a 1800 RPM
motor or something,
motor, pump, fan, whatever. Most of the time, by you see that in just a velocity spectrum, it's already too late, right? I mean, the failure's already there.
Sure.
If you're seeing it in the velocity, your forewarning, your time to plan is very small in most cases. So that's why we say like vibration, thermography, oil analysis. Some will say oil analysis. It's just not suited for low speed, right? Because low speed is not going to generate heat typically. I'm sure somebody will come on and say, well, you're wrong. We've seen this, but in most cases, it's not generating a lot of heat.
Sure. Everything's subjective too, right? I mean, you could say fluid analysis you would have less at such a low speed, you'd have less wear material deposited over a certain amount of time, right? I mean, that's general too. That might not mean every single circumstance.
Well, right. And a lot of the people I like to talk about the PF curve, you got the design, you got the install, right? You got infant mortality in there. And then they say you got the onset of failure,
random failure, and then you have wear out failure.
Right. So a lot of people like my friends in the ultrasound, they'll tell you they're the first ones to detect that, which ultrasound is great for early detection, low speed detection. They're using stress wave detection. And the one thing I don't like about the condition monitoring PF curve is they'll say stress wave, vibration, oil, grease detection, and then performance degradation. The thing I don't like about that is I've seen a lot of cases where oil and grease have detected things way before vibration has.
I always said oil was the first one. That was just me, but I'm not a vibration ultrasound expert. So,
well, the space is, like I've said before in a lot of our talks and in conferences, I think the number out there is 86% of companies use vibration analysis as high percentage is what I'm trying to say of the technologies used. Right. I think it goes vibration and then maybe, oil, ultrasonic, some of that. Right. Oil is always treated like the redheaded stepchild, right? It's a very niche thing. I had all my certifications in it years ago. I don't do it anymore. So I don't, I say I'm certified, which I am, but
I'm just trying to get on good graces with my boy Rich and my girl.
Rich is a guru, man. I didn't realize what was capable until we all were hanging out down in Chicago, and I got to spend time with Rich.
Oh, dude! I go to his house, and he gives, every time I'm there working with him, he gives me the master class.
Oh, that's right. You guys are virtually neighbors.
Yeah, he's right up the road.
Yeah, that guy, man. If you could, there's certain people that we know in our circles that if you can spend 5 minutes with them, it's amazing. Him being one of them, he Definitely. Could sit and talk on this, but unfortunately, I think the oil guys, there's not a lot of competition, right? There's only a handful of like IoT things in that right now, where vibration and everything else, it's so huge, it's so muddy, it's so congested, right? So, right. So talking on that, we'll get into that a little bit too, but I don't know. At that we could go on that conversation forever. But the biggest thing to wrap up that side of it, really, Bryan, is lack of training and understanding. I think, again, going back to what I said about 86% of it being, condition monitoring being vibration related, many using the techniques, right? I think it's you and I, and we say you don't know what you don't know a lot of times, right? Or people in reliability and stuff like that. So vibration analysis is not like there's there's schools, right? I mean, Vibration Institute, Mobius, and now, there's 8 million instructors out there. But
Right.
it's not something that you typically learn, say, like a millwright, right?
No, no, it's
Or
not
an
like a
electrician.
niche. It's not like a craft, right?
Right.
Yet,
So you're
yet,
usually
yet.
right. It's kind of like learning an instrument, right? I mean,
Correct.
I played in bands my whole life. It's like, but when I started, it's like, learning how to play guitar and stuff like that. You really sometimes you only become as good as your instructor, right? So
Yeah.
that's kind of the same thing with vibration analysis, is that you learn what you learn from the guy in front of you. And
Right.
sometimes they just don't know those other technologies. So that's always been a big hurdle, is advance, and most of the time it's advanced type of analysis, and you use a lot of time waveforms. Um, and a lot of people new to vibration analysis, time waveforms scare the hell out of them. They don't want to learn how to analyze them. They make them nervous and stuff. And that's really where you got to look, in my opinion, with the slow speed stuff. So that's one of the things. And a lot of times this stuff's not monitored, just from, I guess if you want to say cultural, I say mentality, is a lot of people look at something like a 90-ton Yankee roll and say,
Yeah. It's going like this.
yeah, we're,
And you're like, we'll
Yankees
catch it.
probably,
We'll catch it if it breaks. It's going
right.
slow enough. We'll know.
I shouldn't say Yankees. Those are pretty quick, I like 60 or 80 RPM, but like, like we were just talking about DD washers and stuff, and those, Hagelin drives and stuff moving at 0.5 RPM.
Yeah.
People will look at that and say, that thing will never fail in my lifetime. So,
Right.
and then in reality, they're back in the shop praying to the
I mean,
vibration gods that thing does not fail before they retire.
yeah. Let me just say though, I've worked on Hagelin drives. They are very robust. They are a good drive.
Oh yeah.
And they're not too difficult to rebuild either. I used to rebuild them for cranes at Avondale Shipyard.
Oh yeah. Yeah. But when they do fail,
Hell, it's a mess.
it's a mess, and it's a pile of money and a pile of time.
Yeah.
Again, that goes back to the cultural discussions that you get into with other people. But, lastly with that, the biggest thing is data acquisition time. So the slower something is, the longer it takes. I mean, you could take minutes, and most people, whether it's a service company like I used to be into, or in-house programs, they're not going to stand there with a portable data collector for 10 minutes at each bearing, right? I mean,
Right.
time is money. Let's be honest,
Especially
right?
if it's not like that ball mill behind you. Look at all them in a row,
Right.
you know?
So that's kind of the thing, and it's not really ideal. Again, for what I'm saying, it's slow speed monitoring is not ideal for route based or IoT type stuff, just because either the time, the time to take the data on a route base, or some of the MEMS type technology isn't advanced enough to look out far enough to
Sure.
pull that data out sometimes.
Right.
Any questions on that as far as the
Hey, I'm learning.
limitations? I know I'm ranting, so
Hey, no,
stop me at any time.
I want, this is the forum conversation I want because it's easy to just talk about all the theory and everything, right? But like you're like for me, like yeah, I understand it to a point. I've never done it.
Sure.
You know what I mean? And um I think a lot of people out there, including me, are just very curious about the reality of super slow speed. When you told me point one of a point one of an RPM, it's like what? Like if to me, like just being honest, like if I had a machine that was running at 1 RPM, I probably wouldn't put vibration on it. That's just like my first thought, right? My first thought is like, hey, this thing is so slow, that bearing will never die. It will meet L100 or whatever, I forget what they call it for bearing life
Right. The
expectancy.
L10 life.
The L10 life, yeah. They're like, it'll meet the L10 life 10 times over, right?
Right.
But there's this whole other side of technology and investigation that you participate in that is like, well, maybe.
Well, that's just it, right? And that goes back to what I just said a few minutes ago about just the mentality of it and what the culture is around
That's right.
in a particular plant as far as um, monitoring those assets. And I'm going to tell you, it's not the same across every industry, which I'll touch on a little bit here. But some industries are okay with, like you said, running to failure. You see that more in certain industries, and then you see certain industries, like say foundries, where it's dirty, or chemical plants. And I've been in foundries where they might only want to check things twice a year,
Right.
and they got all this dust and dirt intrusion into the bearings and whatever. And sometimes those things make you look stupid. I mean, there's other vibe guys who might listen to this podcast and laugh and say, yeah, I've called. You think that these things would fail much quicker, and they don't. You wonder how in some of these atmospheres these things keep rolling, but
Literally
keep rolling. Right. I'm not that clever, but thank you.
Damn, good pun, man.
Yeah. Performing all day.
So talking on that though, unless I interrupted your thought, like
no,
let's talk about the industries. Who's using this super slow stuff?
So where I'm seeing it, and four came to mind. I thought, well, what kind of industries, can I talk to Bryan about on this? So four of them, I'll start with like food and beverage, right? Most people wouldn't associate that with food and beverage, but augers. So just like a case study, so I'm from Wisconsin, so a lot of dairy producers, right? Cheese makers.
You're a cheesehead.
I'm a cheesehead, right? So there's augers and mixers involved in that dairy process of making cheese and the whey and all that other stuff, right? Very slow speed, very time consuming.
I didn't think of that.
Yeah. So you got gearboxes that run that stuff, right? So you can have, and they don't have to be monster assets, right? Like I'm saying, like a 90-ton Yankee, but if that stuff goes down, now you're talking about like food spoilage and stuff like that. Or say if an auger deflects, right? Sure. So I'm working on a trial right now where a company has large, so cheddar cheese will come in large slabs, right? Down a conveyor, and it'll spill over into an auger, and that turns it up and takes it down to the next process. Well, sometimes if that's not cut properly or it doesn't, crumble apart properly, it'll actually deflect that auger.
Oh, sure. Yeah.
And everybody loves Wisconsin cheese, but nobody wants to come to Wisconsin and eat cheese with stainless steel in it, right? So that's a thing. So it's like monitoring that and be able to pick up those impacts and different things, or bearing failures if something was to seize up and something like that. Steel mills, a lot of steel mills over here as well. So rolling mills. If you ever walked in a steel mill, you see these monster rolling mills. Very slow speed in the gearboxes, very slow speed as those things are rolling up. And another very expensive asset, if something goes down with those. And I would say the last industry, I mean, many industries, anything with conveyors and stuff like that. But again, it comes down to cost, right? People got to do a cost benefit analysis, things we talk about on the reliability side. If you got a conveyor with a bunch of little, 6308 bearings or something like that, nobody's going to check that. Like you said, the cost is that they'll run to failure and they'll quickly change it out. But the pulp and paper industry is probably the biggest, and that's where SPM really excelled, and where our technologies, which I'll touch on a little bit later, is that's where it was all really, the research was done in the pulp and paper mill, because there is so many slow speed assets in that. Unique in the sense that most paper and tissue mills operate very large assets, right? So I don't know if you're familiar with like Yankee dryers, which can get up to 90 tons. So Yankee dryer is a very big cylinder, paper goes over it. I know I don't want to get beat up by any of my paper friends, but that's very simplified, goes over it, right? Pressure rolls in the paper industry, TAD rolls, which stands for through air dryers, same type of things. Slow, 60 to 80 RPM in most cases, but very critical. And, if you have a paper machine seize up and that roll, it could be a big safety issue, right? So believe it or not, in the paper industry, there's dedicated committees to these singular assets.
I didn't know that.
Yeah. So your big pulp and paper mills, I'll just pick on a few, like Georgia Pacific, Kimberly-Clark, stuff like that. And I just know this because, like I said, I've cut my teeth in the paper industry, worked in it the last 25 years. A little fun fact for you is that the state of Wisconsin, actually has the most pulp and paper mills in all of the United States. And we've probably lost more in the last 15, 20 years than most states have in them. Pulp and paper industry has taken a pretty heavy hit over the last 20 years with competition, different things. Tissue, not so much. But So anyways, they have committees dedicated to these assets. And then most of those guys and women that run on those committees are also part of larger committees which I'm actually excited about. I got to give this a little plug, but I'm actually been invited to present on this very subject to Tappy this fall for their fall get together. I don't know if you're familiar with Tappy or their conference that's held every year, but they're the technical associate, excuse me, the technical association of the pulp and paper industry.
I've heard
So
you use that acronym, but I wasn't quite
yeah,
sure what it was. Yeah.
yeah, great organization. You know, they put out a great magazine, a lot of great stuff, letting you know what all the different pulp and paper industries are doing. And I'm a part of that organization, a member, I
Nice.
should say, and really enjoy it. So I've had the pleasure that they've invited me because they know that industry more than most understand the struggles
Right.
with that. Again, and it's not just those big dryers; it's pulpers, screens, the washers, the presses, save alls, all that kind of stuff. Vacuum pumps are all moving pretty slow.
That's awesome. I wanted to ask you a question while I'm thinking about it.
Yeah,
Like we think about, and correct me if I'm wrong. Say the bearing manufacturer that I use is SKF
sure.
or FAG. Just pick one, right?
Yep.
Is it true that based on bearing number, size, and RPM, there's pretty and load, whatever, that there is pretty cut and dry vibration information on most bearing numbers?
Absolutely.
Okay. Is is that data on the bearing proportional as that bearing grows in size and scarcity because it's very custom or very uh niche, right? So
Right.
correct me if I'm wrong again. Like say we're talking about a ball mill, right? And the trunnion bearing on one end is a massive, like giant, maybe a pillow block, maybe it's I don't know what it is. Is the data? Is there a lot of good data on bearings that size and
Well,
that speed?
all bearings. So if you look at, like, say you take an SKF bearing and you look at it, it says 6318. So if you type it into a bearing database, it's going to come up and show you um, what the inner race bearing defect frequency is, the outer race, the ball, the
Even
cage.
even all the way up to these giant ones you're looking at?
Every bearing that's got a number on it has that information.
Okay, okay, okay. I
I
knew.
may be wrong. I've never run into a case of rolling element bearings.
Okay, because
You
I
know,
know for like medium up to the ones that I've dealt with,
right?
I've known that, but I didn't know if like giant ones, if it was the same thing was known, right?
Right. So you can see great big bearings, $40,000 a piece bearings in paper mills, right? Pressure rolls, Yankees,
Right.
stuff like that. Yeah, they all have a number. And that's how we make our determination on that. I
Got it.
mean,
Okay.
that's the beauty. That's the beauty. One thing and I'm not going to, I promise I won't go off on a rant on this, but that's one of the beauties of a good in-house program is that the men and women that are in-house that are employed by those paper mills, we're just going to talk about paper mills. They have the time, right, to look up that data that you're talking about, which is key versus um, outside services. Now, whether that's a SaaS program with the newest IoT stuff, or if it was condition monitoring companies like I did, a lot of times you're not going to get that. That normally you're only called when somebody needs an alignment in the middle of the night or a fan
Sure.
balance, or whatever. It's really hard. It's like extracting teeth a lot of times, getting that information. But if you have that information, like a lot of good in-house programs do, because they have that readily available to them, or they have the time to go look for that
In their CMMS.
in their CMMS or wherever that stuff is, right, is key,
Right.
especially I think it was about 10 years ago, a local paper mill here just up the road from me. I had called a bad Yankee bearing, and that bearing was specially made for that machine 40 years ago, and
Hmm.
they did not have one on the shelf. So the bearing manufacturer, SKF or whoever it might be, had to retool for that, and their lead time was like a year to get
Right.
that bearing. So that's another case where
But they wouldn't
that's
have
crucial.
but they wouldn't have that test defect information for that bearing, would they?
Yeah, because that's all in there, right? When they're manufactured based on speed. So in bearing analysis, you have synchronous, you have your one times RPM, right? And then all your bearing defects and stuff like that are subsynchronous. So based on the RPM, so if it's saying you put in the RPM, put in the bearing numbers, and I don't want to spend a lot of time on this in deep dive, but that's all there. There's I guess is the word imperial databases put out
Oh,
by all these
okay.
manufacturers.
Okay.
In most software, whether it's ours at SPM or Emerson or SKF or
Okay. I see.
everybody else, they have a space in there that you can put that in. So when you're doing your analysis, um, you know, you can one click and all of a sudden, if you have all that accurate information in there, it's there. A lot of companies now
Yeah.
call it like they're calling it other things, but AI and
Yeah.
all these other things, but it's actually been in there for as long as I can remember as far as
The only
pulling that
reason
out.
I'm beating on that question is because I remember working at the port and working on Holland Patterson rail car dumpers. Literally, they roll rail cars over, dump them
Mm-hmm.
into a pit so that coal can be dug out of the rail car and loaded on trucks. And this machine was built in like the '60s, and it had two giant trunnion bearings at either end. Um, and when we replaced them at one point, trying to get somebody to find that bearing, it was like no one could find the bearing because there was like no number on it. It was like someone made or that they made, and it was just a very difficult bearing to find. And I just didn't know if time and or complexity or nuance of bearings could deceive or change the amount of information that is available to that bearing. That's all.
Right.
And
No,
I
the
mean,
information's there, and you bring up a very good point. And back to my point of that story that I shared about that mill not having that bearing on the shelf,
right.
and being told it would take them at least a year to get that bearing. Um, that's huge to what
Yeah.
you're saying. Again, picking on the pulp and paper industry, if you look at the pulp and paper industry by and large, it's a lot of old machines. I mean, the fastest machines are not here in the United States. Um, and that's why, sometimes I talk about, the importance of human analysts to be on site is the nuances of those older machines. Because most machines now, they want to speed them up. You've talked about it before. I've talked about it. Things running out of design and what that
Mhm.
does, right? And
Mhm.
that's a very common problem
Yeah.
in industry of these older machines, right?
We
Instead of
need we
instead
need
of
to
retrofitting them or
yeah.
doing whatever, it's like, well, let's just speed them up on the VFD.
Yeah, let's trade away tomorrow's reliability for today's production.
That's right. Production, production, production.
Yeah.
So,
All
anyways,
right.
we'll keep rolling into it.
Sorry for the
So,
derail. Keep
no,
rolling.
no, that's great stuff, man. So, I just want to touch on some of the techniques out there too. And like I said, I'm not uh, gonna just beat you up on SPM stuff, but a lot of the techniques that have been out there, spike energy is one of the older ones. Acceleration enveloping is one you may have heard of that people still use. Um, Demodulation is a word. Peak view, which is a proprietary thing to Emerson's software, again for early detection and stuff like that. That's been out a long time. Um, Ultrasonics. Um, ultrasonics has been going pretty strong, I think, for the last 20 years, even though it's been out, I believe, since the mid 70s, right?
Right.
More and more people are grasping onto it because much like our SPM shock pulse, it's more simplified, right, than having to learn vibration analysis.
Yeah.
You know, so ultrasonics, that's more of a stress wave detection, right? Audible stress wave detection. And I'm sure I'm missing some out there, but I just want to make sure I did my due diligence and give credit to everything that's kind of come before and everything else that's being used out there. Again, that's kind of like what you were taught, right? Much like what we learned from our parents, our whether it's our religion, our politics, different things that are ingrained in you right from the beginning
Sure.
because that's all you've ever known, right?
That's right.
But that's the way we've always done
Yeah.
it.
Wow, you
So
sound like a lot of people I know.
yeah, I know. So not saying all those technologies are great, but I got to mention it because a lot of people are still using that because that's what they learned on.
Sure. Yeah.
Like I said, and I'm sure I'm missing one, and a lot of them have similarities. And then you have our technology. You and I've had conversations on the shock pulse. Um,
I've seen it firsthand.
yeah, a few times. Very simple technology. Uh, that's instead of a stress wave detection, it's an elastic wave detection, right? Um, so those elastic waves, as you know, are created as a result of, how would I say it, collisions of
Yeah.
two rigid pieces of like two
Yeah.
metal, like so a ball bear.
Microscopic.
Yeah, a ball. Well, the ball and then the raceway, right? And if
Sure.
there's a spall in there, that's what it's detecting. It's picking up uh, those elastic waves. And that technology is designed initially and still designed for detecting mechanical and lubrication problems. And that was patented way back in 1969.
Hmm.
And it's really one of the best technologies that a lot of people don't know about still. I mean, the shock pulse, it's such an easy tech to use and it's
I
very accurate.
I didn't know about it until I met you.
Yeah. So again, that was in the late 60s, mid 60s, that was developed over in Sweden. And
Right.
then I think shortly after that, again, like the based on kind of the same concept of monitoring and recording in decibels, was the ultrasonics.
Right.
Came out in the mid 70s. Um, but the latest technology, again, produced by SPM, we took that shock pulse. I shouldn't say we, I wasn't part of that, but they took the shock pulse and made it so much better with what we call our HD technologies. So SPM HD, let me back up. So SPM is involved, obviously SPM, the name, shock pulse method. That's where they got their start. They branched into conventional vibration analysis as well. I got to clarify, because some people, when I talk to them, they get confused because they're like, well, you're just a shock pulse people. Like, no, we're also, on the forefront of the vibration world as well. So in 2010, they launched SPM HD, and basically they took the original shock pulse, digitally refined it. It made it applicable to all types of applications, and that's where it really was particularly well suited for low speed machinery. And it's got the most crystal clear spectra and time waveforms you'll find anywhere on the market. And again, like I said, capable of monitoring down to 0.1.
What type of, we talk about 0.1, what's moving that slow?
Well, the biggest things are like washers, DD washers in the paper mills, like we were talking about, Hagelin drums are like 0.7, somewhere like that. I personally haven't monitored down to 0.1 yet.
Sure.
We have case studies on our website that talk about that. And
I mean, even 0.7. I mean, like, that's slow.
well, yeah. I mean, 3 RPM is slow. 100
Right.
RPM is slow, and
Right.
and goes back to what I was saying. I mean, it's super difficult if you don't know how to set it up or how to use those technologies I just talked about correctly. Right.
Right. When I think about RPM, I always envision a lathe that you can set your RPMs for your feeds and speeds
Right.
with like a manual lathe. And like I think 100 RPM is pretty slow.
Oh, absolutely. The great thing about the HD technologies, and where I'm trying to get the word out, is that it's so far advanced visually and in the forewarning times. I mean, we have case studies of monitoring assets for people for 2 years, and I'll show you some neat pictures and stuff. But for me, that's the stuff that I really love. That's the fun stuff,
Right.
is being able to see that.
Well, that's where the
Um,
value is, right?
right.
That's the culmination of doing the work and providing the solution for somebody is that forewarning time.
Well, it really is, So that's the one side, and I'll touch on that in a minute. But that's on the one side. On the shock pulse side is the SPM HD, and also the cool thing about that is they were able to then, and I think they do it in ultrasonics as well. I'm not going to pretend like I'm an expert in it. I used it a little bit in my previous life, but they were able to overlap FFT on there, so you could actually, instead of just getting like what with the shock pulse, just a dBm reading.
Sure.
You can now pull out a time waveform from that data, and you could look at a crystal clear spectrum
Hmm.
and a crystal clear waveform,
That's cool.
which was very groundbreaking and very cool. And it was another great feature for the people using the shock pulse tech.
Right.
And then in 2015, which is the newest technology, to the best of my knowledge, is still the newest technology in the vibration world, and that's our HD enveloping. So a lot of people say, what's all this HD stuff about? They think it's a buzzword, right? Because we live in the age of buzzwords, but it's really not. It really is high definition. So I always tell people it's the analogy of like, simple analogy is 4K Ultra HD versus 480p. How do you want to see your data? Do you want to
Right.
see it at 480p, or do you want to see it crystal clear, no doubt, good visuals for
Well,
reporting and to going to people?
if you
That's
think
really
about
what it
that,
comes down to.
if you're looking at waveforms, you're looking at lines. Lines aren't straight, right? They
Right.
have dips and peaks and valleys. And the closer and more clear you can see a line, the more closer and clearer you can see the peaks and valleys and deviations in that line, right?
Right. And like I said, we're not the only ones, doing any enveloping and different things like that. We just do it better. I mean, that's a bold statement, but we really do. I mean, the visual on it is amazing. And when I sit down with people who are looking at it, they're like, wow, that's amazing. And it
Yeah.
takes a lot of the doubt out of it. Right.
I mean,
Um,
I'm a dumb guy, and when I was at multiple conferences with you looking at this technology at your booths. Even I'm like, guaranteed I have no frame of reference. I'm like,
Right.
damn.
Yeah, it's cool stuff. It really is. It's wild. I think it's got like 30 patents behind it. That got quite a ways on them yet. It's they really pioneered with this thing. And and the other cool thing is it utilizes the shock pulse sensor. It's what we call our Duotech sensor. So it's one sensor that monitors vibration and shock pulse.
Yes, that's wild.
Yeah. And so you really get a lot of great data out of that. Using our HD technologies, the enveloping technology, you can use our Duotex or you can use any good 100 millivolt per G transducer. It has nothing to do with the sensitivity of the transducer, like we used to have to worry about. I mean, to monitor low speed stuff even. So
Right.
it's really easy to use. The filtering in it, which I'll touch on a little bit, and then we can just kind of have a Q&A, or I'll show you some pictures. Uh, um, a lot of times, like I said, going back earlier about the understanding of it, when a lot of this enveloping technology came out, a lot of technicians just weren't sure how to set it up, wouldn't get good data. The time waveforms, whether it's Technical Associates, Vibe Institute, Mobius, they have dedicated classes to learning how to master looking at time waveforms,
Right.
where by all means, if you want to be a great analyst, go to those classes and learn the time waveform. But where the beauty of our data is, it really cleans that up, that time waveform spectrum, and you can see defects clearly. Our filtering, like I said, I think it's hands down the best in the industry as far as forewarning times.
Right.
To be able to pick that up, and you can watch that bearing defect all the way from, just coming to the surface or subsurface all the way through the enveloping spectrums, acceleration into velocity, and that's really the name of the game now. It. I mean, you're in the industry every day. Everybody. You don't see the maintenance downs like we used to. When I started out in the repair facilities, I basically worked and slept every 4th of July and Christmas in that repair facility. We worked 24 hours straight, refurbishing great big motors for the paper mills, foundries, steel mills, whatever, on those holiday downs. Now you don't see it. Nobody's shutting down. I got one customer I talked to yesterday, and they're planning for their annual down. Other than that,
They're running.
it might be a few hours here and there, but there's no massive downs anymore. So for warning time, I don't know why more people don't talk about it. Everybody wants to talk about sensor technology and this, that, and the other thing. But honestly, the biggest thing that nobody cares about your bells and whistles, right? They don't want you selling them a pitch on bells and whistles, this and that. The thing that people need to be talking about is, how much time do I have to plan, right? Because maintenance planners and schedulers, it goes back to what I was talking about, everybody having a seat at the table. That's kind of what I talked about a reliable plant this year. And these planners and schedulers and maintenance managers, I think they need more say now, because if it was up to them, they'd be like, yeah, I know we don't matter. I shouldn't say it don't matter, but production, like you just said, matters, right? Production. And they only got that small window. You want to give these folks the biggest opportunity, the longest to plan for,
100%.
make sure those bearings are there, because we all know COVID, that exposed our supply chains, right? So it's like, with all these extra lead times on getting things, going back to what I said about that one bearing, waiting a year. Well, what are you going to do? You're going to mothball your plant?
Yeah. Yeah. No. So let me ask you this though, real quick. One thing that correct again, if I'm wrong, tell me. One thing you can't monitor through is improperly placed and uh, installed sensors, right?
Right.
And I was at a couple places over this year, and I was sending you some pictures, and you and I were chatting about the locations of some sensors that were put on by experts
Mm-hmm.
in condition monitoring, and they turned out where they were in the worst place that they could be attached by, the worst means that they could be attached by. And would you agree that if people are going to be doing condition monitoring, vibration, they're going to have a remote setup or whatever, that the people need to know how to set these things up, where they should be, how they should be attached? There needs to be people physically in the plant who are going to be monitoring these things, right? There needs to be that connection to the asset. Would you agree?
Yeah, I'm going to plead the fifth because I've gotten a lot of hate mail this year on calling some of that stuff out, and it's really not calling out. People misinterpret me as calling things out and looking for clicks. That's not the case. That's not who I am.
Well,
I'm a guy. I'm a
there's a
guy who spent
reality.
a couple decades in the field. And the reality is, again, it goes back to they don't know what they don't know. So a lot of times on the remote side of it, it's a great technology. I love the wireless technology.
Me too.
SPM is a leader in it. I love it. The problem with the sight unseen analysis, I could go on a
I
few
know.
things, but the biggest thing is a lot of times they hire people regionally just to go out and mount sensors, and they might not understand or have the full training on or understanding vibration. They're a mechanical guy told to just go glue a sensor on or stick it on with a magnet, not understanding the implications of certain applications, right?
Right.
So, yeah.
But your data will be impacted by those things.
It can. Some people say, well, it doesn't matter. And in some instances, if it's a 3,600 RPM motor, yeah, it might not. It's going to transfer through. But I'll tell you what, in the slow speed world, you better have it together. So I always say in slow speed, it better, again, one guy's opinion. But if it's my plant, I'm stud mounting everything and I'm hardwiring everything to an online system that I can integrate in. I'm not doing route based on it because one, I'm not going to have guys standing there for 10 minutes per, an hour per asset. And I'm not going to take a chance on technologies that just can't pick it up, because we're talking massive amounts of money when these things go down. I mean, well, you always see all the ROI things out there, right? It's kind of wild. Like that's some of the numbers people put out.
I know. CMMS companies do it too. They're like, our customers save $14 billion in this. And I'm like, where? Where?
Right.
I'd love to know where that was.
But I mean, on a realistic level, I've got paper mills that lose anywhere from $80,000 to $100,000 an hour when that
No
goes
question.
down, and not to mention all the other stuff that people don't talk about.
Standby labor cost, production
labor
capacity, missed opportunity.
There it is, man. There it is, man. That adds up. That adds up so much, and so yeah, really that's a huge thing. And that comes back to that forewarning time I was saying. But yeah, sensor placement is everything. In a lot of cases, sometimes you just can't do it properly. I think some of the problems with one of the problems with what we see out there with those poor sensor placement is, I think, again, in the world of IoT and MEMS, there's no standardization. And that's the problem, in my opinion, with some things. People don't understand it. Back in the traditional world of vibration, everything was pretty much standard. Everybody was doing things kind of the same way. Some just had the bells and whistles were a little different, right? But there was a general understanding and a standardization on the sensors used and things.
Right.
But with the IoT world, that's not really the case, right? So I think some sensors, because they're triaxial, they have to be on there because their software might not be advanced. They might have. I've seen where some companies have a great sensor, but horrible software. So to where the software can't be programmed to say, okay, this triax is going to be here, but now we're going to assign these 3 points to still be relevant. You know what I mean?
Yeah.
I know I went off on a rant. I don't know why I don't know why you bait me into them things, but I'm just kidding.
Because look, there's a lot of varying understandings, and like I said, I've been a part of setting up condition monitoring programs. I've witnessed people doing it themselves. I've helped people not with the sensor side of things, but the overall management and maintenance management of things, and there are things that just sometimes have to be done right in order for you to get what you want out of it. And if those things are overlooked, you're not leveraging the full capability of what you've paid for.
Well, talking about it really is, like I say to people, it's such an exciting time to be a part of condition monitoring because there's so much neat technology out there. The motion amplification stuff is cool.
So cool.
The stuff that Howard's doing. Howard, I love you,
cool.
but I can only handle about 20 minutes of conversation with him because then my brain starts smoking because it's, he's so intelligent with that tech that he's using and it does such an amazing job on the energy saving stuff.
His is like forewarning too. Like he's looking at the electron change and the magnetic field changing in something before it fails. And like,
I'm pretty sure he's testing monitoring on Mars currently. That's why I probably haven't heard from him. But
Yeah.
I'm just saying, his tech, the motion amplification, all that stuff that I didn't get to play with when I first started out. Even our tech, there's a lot of neat stuff out there. But I think it really on the service side of it is where it's lacking. I think because there's less people in house, and in my opinion, I'll just come out and say it. To me, that's the best programs in house. I get hybrid stuff. I talked about it. I taught on it. But the problem with sight unseen, in my opinion, Bryan, is they make recommendations and everybody throws around, prescriptive this, prescriptive that. Well, prescriptive isn't new. I mean, prescriptive has been done for 80 years in oil analysis and vibration analysis since the 40s.
Right.
If you're not offering us a solution through the data you're getting prescriptive,
Right.
then there's no reason to do it.
Right.
But if you don't have somebody that can follow up on it, right? So if I go into paper mill and say, hey, I've noticed, or they call me up and say, hey, we noticed we got this weird vibration. I go in there. Well, how am I gonna look at that 90-ton or that Yankee and monitor that it's got a roll profile issue, right? There's a wave on the top of that thing, or a rubber roll if it needs to be reground or something, or if the felt or the wire going through the machine, if there's a defect in that. Those are all things we can pick up through more advanced analysis, right? So those types of things, I think, is where it suffers. Or if somebody needs to monitor something more closely and go out there and relook at it, right? So that's just a facet of it. Again, I don't want people to think I'm beating up on any of it, but I think there's definitely a gap. And once they can figure that out, I think we're going to advance even more, because like right now, like I said, a lot of the sight unseen, they don't have boots on the ground.
That's right. And that's
it doesn't make them bad. I'm just saying it makes it not as streamlined as condition monitoring once was, because now it adds in, I have these guys, now I got to call these guys. It's kind of like the state of the medical world, right? You go see a doctor, you pay him $800 just to basically recommend you to go see the specialist.
Yeah, and then you pay him $2,000.
That's what condition monitoring is becoming. It's like, we'll tell you that there's an anomaly, there's something going on, but if it's not that, well, then you need to go see this person.
Yeah,
and
the one thing, the worst, not the worst, but a really bad thing is, hey, we need to stop it just to see.
Right. So let's show you some stuff and we'll wrap it up. I was going to talk a little bit about the enveloping technology, but we'll skip that. Most people understand that, but let's show you some cool stuff here quick. So bear with me. I know we were trying to do this before.
Matt's going to share his screen.
Matt is going to share his screen. Everybody do this, with your eyes, just in case I share something I don't want to share here.
Yeah, trust me, I'm not good at it either.
Well, if you would have done Teams like the rest of the world instead of this.
No.
What is this? Facebook Live, Bookface, or I don't know. Are we on Twitter now? And
this is Boost Mobile Radio.
Boost Mobile, TikTok, Bookface Radio.
This is Cricket Wireless Podcast.
All right, you picking up what I'm laying down here?
There you go. Yeah.
All right. So it gives room to plan and act. That's the beauty of the HD technology.
Can you make it bigger? Make it bigger.
I don't know, man. Let me try.
Use your little. There you go.
Hey.
Why is
the beauty of touchscreen technology, baby?
The half of it's dark, the other half's light. Why is that? Do you have it half highlighted or something?
No. That's the visual, right? So it says give room to plan and act. This is just a good visual for that, because with conventional vibration analysis, looking at velocity spectrums and stuff like that, all you're going to be able. Can you see my mouse as well?
Yeah.
All you're going to really pick up is here. Advanced warning through the HD stuff. We're already picking stuff up here, just outside of healthy bearings. So all healthy bearings have some kind of inclusions, right?
Right.
Or subsurface cracks. That's just the way it is. It's there. So we start picking up way out here, and that's the beauty of watching it through the filter. So what we would call like this here, like filter 4, we'd start seeing something.
That's cool.
And then filter 3, it's going to come in. And then by the time you go through that whole cycle of that flaw, if you will, that defect, to here where now you're going nuclear and on the verge of catastrophic, right? So that's just one thing I wanted to share. That's really cool. That's the beauty of the tech in the early warning. And this is the same for slow speed analysis. We can pick that up way out here, like I said, through our software, through our HD filtering, and be able to pick that up.
And that's wild. That's wild.
you were asking about, like, here's a cool one. So am I running out of time? You got to interview Greg or somebody?
No, no. I talked to him a
So,
couple of days ago. He's good.
all right, let's share this again. So here, can you see that one?
Yeah.
So
Oh, there it is.
that's a big Hagelin drum.
Oh
So that's
yeah.
something you can see. We got the one sensor there, a Duotech sensor monitoring that, and then the Hagelin. Then we got another sensor down here monitoring this drum bearing.
What's that?
Um,
What is that? What's that turning right there?
this is a washer, an
Okay.
Andrite's washer. So for pulp, for I don't want to say customers or nothing like that,
Yeah,
but
no, no, no.
this was a very critical asset that if this went down, the whole plant would go down.
Oh
And
shit.
there was an issue, and we were brought in to monitor it, so they could let's just say a long time out, plan for getting it repaired.
I see they have a quality breather on their hydraulic tank back there too. Good
Yeah.
stuff.
Oh, good. What else do I got here? So I'll show you that. So this is here's data. Um, this is cool. You'll like this. So I'll make that bigger. Can you see that one?
Yeah, yeah.
So that's our HD time signal. Most vibration people would look at this and say, wow, that's a great spectrum of an inter-race bearing defect. That is what our time waveform looks like. And as you can see the revolutions in there, and that's at 15 RPM. So how cool is that? You got your frequency of the inter-race. Side bands are coming up of shaft speed. It's gorgeous. This is great. I wish I would have had this in my on-site career, because it just would have made things so much easier with so much of the slow speed stuff.
That's
Just
awesome.
to pull that out of the weeds. It filters out all the other crap, and
Right.
it's gone.
So what did you, sorry, just for my own ignorance, what did you, so the tallest spike there is what?
This here,
That's the defect, right?
that's the fundamental defect frequency.
A fundamental defect. And then, so
And
that's
then the
how,
rest of our harmonics of that.
okay, got it. That's awesome. Yeah, you can see, like I said, that very bottom line, you can see that's considered a straight line, but there's all these peaks and valleys in that line,
Right.
which you can see through that clarity of that graph.
And here's the defect. And I'll show you two more. Ooh, it's not there, is it?
Nope,
You
that's the
still looking
graph.
at the same one?
Yep.
Is it there now?
Yep.
So you can see that there. You can see that.
Oh, come on. It took sensors to see that. I'd have
Yeah, I
found
know.
that.
That's what I said. That's because it's super. It's increased, but that's at 15 RPM,
I could have
right?
found that with a long screwdriver.
You could, if it was going 3,600 RPM, it'd be really simple. You wouldn't need to spend money on technology. We'd just go old school broom handle with that, brother. But that's the beauty of something going slow, and having being able to pull that out,
Right.
and being crystal clear.
Right. That's cool.
I'll show you one
Were
more.
you on site for that pulling apart, or they send that to you?
That was I was not on site for that. All right, let's see here if I can get this to show up. I'm going to show you two more, and I'll cut you loose.
Thanks for letting me go.
So there's another spectra. That's a beautiful spectrum of
Make it bigger.
another
Make the window bigger. No,
of
no. Make it full screen.
make it full screen.
Yeah,
Oh,
right
I'm
there.
sorry. There you go. You
Yeah.
got it. So
Yep.
that's on a mine hoist. That's a 52 RPM mine hoist.
Hmm.
In a great big gearbox, output 52 RPM. Very short cycles a lot of times. So that's all another thing in the software that we can do, but that's very cool. I wonder if I can just bring this up and show
I
you.
mean, it is really clear. I mean, even down to the bottom of those.
Can you see the bearing now?
Yeah.
You can see that?
Is that a bit of a flake? Is it flaking?
Yeah. So that's the defect from that right there. How
At
cool is
50
that?
at 52 RPM.
52 RPM. Now, some will come on and hammer on me and say, why'd you pull that so early? So this was a proof of concept, where we brought in and we could show that we can put in. When we pulled it out, it was under we let them know that this is going to be very early.
Mm-hmm.
Right. So
That's
that
awesome.
bearing there, we probably could have monitored for another year and a half, if not
Right.
more. It wasn't my case study, but just hypothetically, that probably could have went quite a bit.
Right. And was this a fluid lubricated or just grease lubricated bearing?
Mm, this would have been fluid, I believe.
Okay.
I believe. I'd have to look. And here's my last slide. Can you see that?
Yeah.
So
This
this is
looks familiar from that software that you showed.
right. So this is from a steel mill here in the United States. Again, you can see this was going. I think this is like this is fast. It's 200 RPM, but you can see the beauty of it visually, right? So instead of down here, usually a typical time waveform has all kinds of stuff going on in there, and you got to get in there with your markers and things like that and decipher everything. But you can see our time waveform; it comes out crystal clear, looking just like our spectrum.
That's cool. And what's the bottom? What's the bottom right there?
So that is a circuit, what we call a circular plot. So you can actually see those impacts from this interrace defect.
Ah, okay. So you're that's essentially modeling the radius of the bearing.
Right. So some people like to look at time waveforms. The more advanced guys, they love this stuff. Spectral analysis is great, if they're trending in that. And then the circle plot's just kind of a icing on the cake of looking at things. I mean, we won't deep dive in that, but there's a lot of applications for that as well.
Cool. That's awesome. One last question for me. Thinking about like fluid lubricated bearings, and
Mm-hmm.
if I think about an interrace crack, right? It's likely that that lubricant film has impregnated that crack, right?
Correct.
Does that fluid being in that crack, we know how hydraulics work, as that bearing race is moving and deflecting and that crack is working, are you able, does the fluid in that, does it help you find the defect or does it make it harder? Because that fluid is going to be jacking in there, right? Essentially, it's going to be, squishing in and out and possibly creating more, I don't want to say resonance, but like more movement. Is that, am
No,
I
that's a
off?
great question, and I don't know if I can answer that uh, all the way correctly. I mean, I've seen things where there's been bearing defects, and of course, in some cultures and industry, they're like pump more grease in it, and you might see that go away because it takes up that void. But grease
Right.
always works its way out, right?
Well,
Um,
grease is also it's it's inherently it's thicker, right? So like it might have that characteristic, but like a lubricant, like I always think of like I don't know, like a pump bearing in like with like 10 weight oil or something.
I've
Uh,
never seen where oil will mask a defect.
okay, okay, it won't
Um,
mask it.
the only thing I'm going to go down a quick rabbit hole. The coolest thing I ever saw was um, plastics is huge here in Wisconsin as well. So I had a plastics company, great big extruder, um, 500 horsepower motor going into this very large gearbox, and then you get a twin screw extruder. Say that fast 10 times going out. But the motor was electrically fluted. I know you're familiar with that term, from the VFD
Mhm.
arcing out over the bearings. And I had him pull it, and
It didn't have rings, didn't have ground buffer rings on it.
well, that's another. If you ever want to talk to anybody about that, I have a guy for you that is uh, very good at that. Um, that's a whole nother episode we can talk about. But that's evolved too over the last 20 years. So, anyways, I had them pull that motor out. They replaced it. They put it in 3 months later. When I went back there, this thing's noisy as hell again. And I'm like,
Hmm.
what the hell is going on here? Because typically I'll do that prescriptive. I told them put a ceramic sleeve, bore and house the opposite drive-in, put a ceramic sleeve in there, and then make sure you got a nice big copper bristle brush, grounding brush on it, or I forget what their repair shop did. They may have put an Insicoat bearing in there as well, a ceramic bearing besides that to
Right.
break that. So I'm thinking, how the hell? I have seen many times that these VFDs have got so powerful that they actually spark out over that
They
coating.
jump it. They jump
They
it. Yeah.
jump it.
There's too much
Yeah,
potential. Yeah.
right. Um, but would you believe it, Bryan, that fluted that gearbox? Every bearing, I finally had them shut it down. I went there on the down. I opened up the gearbox and I looked through the inspection covers and I got in there with my flashlight and everyone excuse me, every one of those bearings was fluted inside the gearbox. Now that's not something you see every day. So not, then it was like, I'm like, man, am I making a bad call here? Why is this thing? But it was on the gearbox side.
Hmm.
And I didn't pick that up because in my mind, I mean, maybe I probably should have, but I just picked it up on the motor because you're so used to,
Sure, sure.
I wasn't thinking out of the box at that. I'm like, oh, just another fluted
But it
bearing
in a motor.
in the plastics industry. You
So
see it
that
all the time.
so
90%
that
of them are fluted.
so that carried that was enough to carry all the way into the gearbox.
It carried all the way in the gearbox, but the crazy thing is, I've been gone for 2 years. I still reach out to them because I wrote a paper on it, and that gearbox is still running. And I think because it's not greased, it's oil bath. So what happens with a fluted bearing, and some people might debate this with me, but the bearings typically, they sound horrible. It's like a washboard, right? They sound worse than what they are. But what happens is in the grease bearing, that those eddy currents dry out the grease, burn out the grease, and it goes nuclear. It goes catastrophic. The bearing doesn't fatigue like I was showing you. A cage will fail because the grease gets burned hard, and it's always catastrophic because
Right.
the cage fails, and you're lucky if you got a minute warning on that. But in that oil bath, that sucker's still running. It's been running probably for 8 years now.
Hmm.
How wild?
Crazy.
How wild is that?
I wonder if there we can tap into some of our friends and see maybe why that is. Because
Yeah, I'd be interested in talking to Rich. Like I said, I wrote a paper on it, I put it out there, and there were some responses to it. But somebody like Rich, much smarter than me in the oil thing,
yeah.
might have a good answer for that.
Well, the reason I asked though, because you think about the way fluid works as it's incompressible, if you will, right?
Right.
It does react to compression, but it's not compressible, right? And I just didn't know if that was something that may amplify or deaden what you're trying to monitor at a slow speed. That's why I asked that.
Well, that's where the shock pulse stuff comes in, right? But we're not going to deep dive in that. But that's the beauty of the shock pulse is it can detect lubrication issues over a mechanical issue due to what you're saying, based on those stress waves that come out, based on a lubrication barrier going down, or if it's an actual metal to metal type of rub or a defect or anything like that.
Right. That's awesome. Yeah, I love these conversations, just because I'm ignorant to it. It's not something I do on a day-to-day basis. And I don't know. I just when you talk about condition monitoring in these respects, slow speed, particularly, what you're doing, it's always making me think about the things that I've been or participated in, the machines that I've worked on, big cranes, like I said, rail car dumping machines they don't even do a full revolution. They just do a half revolution, right? And back. And yeah, you just think about past things you've torn apart and fooled with and
Oh
solved.
yeah. Well, those cranes, those are tricky too, like you were saying. I mean, we monitor a lot of cranes, and it's all in triggering them, but like you said, very short cycle, right? And you need to capture data in there. It's that's the neat stuff.
Yeah, and they also
Uh,
work within the same a lot of cranes work within the same amount of boom height and cable length. So
right, right.
you're always in the same spot of a bearing or a shiv or a spool or a drum or a gearbox.
They'll fail, and a lot of times you see this in paper when they rebuild paper rolls. If the bearing's not completely destroyed, they'll take it and they'll move it 180 degrees, and they'll reinstall it and run it again, right? I mean, when you're talking a $40,000 bearing, they'll be like, yeah, okay. I mean, they pull them out, they inspect them all. I'm not a roll builder, but I used to do a lot of acceptance testing of rolls after the fact,
Right.
for a lot of the big roll manufacturers here in Wisconsin. But yeah, that was always wild to me too. Like, yeah, we're just going to turn it out of that load zone and run it again. Probably the same with those cranes that you're talking about. I imagine. Um,
Yeah, especially with Babbitt style bearings, non-roller bearings.
yeah, it's a whole different world.
Yeah, you see, you have the load affected zone. You can rotate things around.
Yeah, well, yeah, Babbitt bearings. Those are one of those that when they go as well. That gets ugly really quick, or if something's not aligned properly and it gets pulled out of electrical center and things fail very, very quickly. Yeah, that's a whole nother discussion, monitoring Babbitt.
Yeah,
See
I'd
what's
actually
in the
like that.
bearings.
I'd actually like to have that conversation because I don't even thinking I know things that use Babbitt, like, of course, engines and turbos and trunnions and things like that. But I don't even know what else uses them.
You'd be surprised. It's huge. It's huge in oil and gas. Oil and gas is probably, and I'm not even going to speak on, it's probably one of the only industries that I don't have a lot of experience in of day-to-day analysis, but they run some really big stuff. Same in power generation. When you're talking 5, 10, 15,000 horsepower stuff, big stuff.
Yeah, you can't
That's
have a bearing.
That's all fluid film bearings. If that's something you want to deep dive in, I have a guy for you, a level 4 guy who is ridiculously smart, comes from the oil and gas industry, and is an absolute boss.
Can he answer all my stupid questions?
Yeah, he loves stupid questions. Why else would he hang out with me?
Yeah. Well, give me his name after this, and I'll reach out to him because I'd love
will.
to have. I'd love
Great
to have
dude. Like I said, triple smart. He's when I can't figure something out, I call him. That's why I network with him, man. He's got a wealth of experience in that industry.
That's awesome. Matt, again, dude, thank you so much. You and I, we're bros. I mean, I'll see you around. I know for sure. If you're in Chicago next week, I think Howard said he might try to stop in. Let me know.
I might try to sneak down. I almost had to fly out to a mine site, but that got postponed. So maybe I'll sneak in and kick down your door. I'll see if I can find you.
Yeah, just give me a shout. And then Matt, like always, if anybody wants to get a hold of you, talk SPM, talk business, talk slow speed, talk anything, how can they get a hold of you?
Well, they can reach me either through LinkedIn, or they can reach out to me through my email, or they can call me direct. I mean, they can email me. I have no problem giving people my number. This is what I love to do, man. This is my wheelhouse. I like to talk to people. And the other thing I tell people up front, I may be doing this a long time, but I certainly don't know everything. That's why I'm really excited. Again, I'm going to beat on it a little bit to see where all this AI stuff goes, because, like you said, you said you're ignorant to some of this stuff. Well, I've been doing this a long time, and I'm still learning, and I still eat crow from time to time. Any good vibration analyst will tell you they're always learning forever, man. There's nuances and things that pop up, or something you only see once every 5 years rear its ugly head. So I love having conversations with people. Call me up, and I guess if I don't have the answer, I got one hell of a network to where I have no problem reaching out and asking somebody who can help them. So
yeah, I mean, that's the best way to do it, right? We don't know everything, but we got to surround ourselves with people who may know lots of things.
And that's what it's about. It's about networking.
Matt, thanks, brother. I appreciate you, and thank you. And on behalf of UpKeep, thank you for not only many podcasts you've done with us, but for being an UpKeep ambassador, preaching the good word, staying true to the reality of maintenance, reliability, condition monitoring, and not all this BS and fluff. And we'll see you on the next one, brother.
Sounds good, brother. Appreciate your time.
Later, dude.